Okay, we're looking at exercise, so mixed exercise 6 from the first year textbook. So this is on circles. So I've got a equation of a circle that's fully expanded, and I'm asked to find the centre and the radius. A little bit of algebra here. Okay, so first thing I'm going to do as I write the question down is I'm going to bring everything over to the left-hand side. So when I minus that 3x from that 3x, I actually don't end up with the next term on the left-hand side. Then I've got the y squared, so I've got 6y, and I'm going to add the 2y over to the left-hand side. And to be honest, the constant doesn't really matter, so I'm going to leave the minus 7 over on the right-hand side. Okay, so then generally you're then completing the square on your x terms and your y terms. However, this one, obviously, it is just x squared, so there's not really anything to do there. So if I complete the square here, it's going to be y plus 4 all squared, and then I minus the 16. And then I'm going to add that minus 16 over to the right-hand side, which gives me 9. And then, so that's sort of what I need to do, but they've specifically asked me to interpret the centre. So the centre, well, if it's just x squared, the centre is x is 0, and then y is minus 4, and the radius is the square root of this. So radius is 3. If the radius ends up as a surd, then you're fine to leave it just, so say that was 10, you'd be fine to leave it as root 10. If this is a square number, then you need to actually evaluate what that would be as an integer, or as a rational number. Find the points of intersection of the circle and the y-axis. Okay, so just a quick sketch to be really clear. So when is any curve going to cut the y-axis? So I could do let's not be lazy. Let's do a roughly accurate sketch of the circle. You don't need one, but let's just get one. So I've said the centre is at 0, minus 4, so over there somewhere. The radius is only 3, so that's completely wrong. Pretend I didn't do that. Right, let's try that again. I'm going to sketch and talk. Right, so the centre is at 0, minus 4, so let's put it in the right place. And the radius is 3. So the fact the radius is 3 means it doesn't cut the x-axis. So they don't need to ask me about that. Oh, okay. No, so I'm jumping ahead a little bit. I'm actually already thinking about part C, but let's calm it down a bit and just do part B. Okay, so when does something cut the y-axis? So when does something cut the y-axis? Well, that's going to be when x is 0. So if we go back to our equation of the circle, so if x is 0, that becomes 0 squared plus y plus 4 squared is 9, so obviously the 0 squared is just 0. I could expand those brackets out and solve that quadratic, but it's going to be way, way quicker if I just square root, but just make sure you consider plus or minus. So y is either minus 3 minus 4, or y is plus 3 minus 4. Okay, and it says points of intersection, so I need to give those as coordinates. So this one is the coordinate 0, minus 7, and this one, that is a negative, isn't it? That one is the coordinate 0, minus 1. Okay, and then, so we've already made a bit of a sneaky head start on part C, because part C is show that the circle does not intersect the x-axis. So I've shown there graphically that it doesn't, and that's from just considering that if the centre is at 0, minus 4 and the radius is only 3, it's not going to go high enough to cut the x-axis. Possibly a clearer way to show it is, let's go back to our equation of the circle. Okay, so using a similar method that we used for part B, it cuts the x-axis where y is 0. So if I sub y is 0 into that, so that becomes x squared plus 16 equals 9, which would mean x squared would have to equal minus 7, which has, let's tell you what, let's put no real solutions, no real roots. Okay, so that has no real solutions, and then it was to show that question, so Very, very clear. That's supposed to be a triangle. So what wording did they use? They said we're trying to show the circle does not intersect the x-axis, so the circle does not intersect the x-axis. Okay, let's just check that they didn't throw anything else in there. No, that's pretty much it.